Okay, continuing on with a few more limit examples today, we have the limit as x approaches infinity of 7x cubed plus 5x minus 1 over x to the fifth minus x squared. And like I've mentioned previously, we could just focus on like the highest degree terms and ignore everything else, but I am going to factor it just to do it kind of carefully. And what we're going to do is we're going to factor out the largest degree term from the denominator. So I'm going to factor out x to the fifth, and then this is going to become 1 minus 1 over x cubed, I believe. Yep, that looks good. And then I'm also going to factor x to the fifth out of the numerator so that we can get cancellation. And then just comparing with this is going to leave me with, let's see, 7 over x squared plus 5 over x to the fourth. And this is going to be minus 1 over x to the fifth. And now this is where we get the cancellation of the x to the fifths. That's nice. But then everything here where we have x's in the denominator is going to 0. So this one's going to cancel. This one's going to 0. This one's going to 0. This one's going to 0. So if we look at what's left after all this canceling, we're going to just have 0 in the numerator, and we still have this 1 left over. So we end up with 0 over, so for our limit, we're going to have 0 over 1, but that's just 0. I think the quick way to do this without all the factoring here, if we have x approaching infinity and the degree is higher in the denominator, this thing's always going to be going to 0. Okay, next problem here. Again, we have x going to infinity. Now, can we do the same thing we did last time? No, but this time we have a higher degree in the numerator. We're 6th degree polynomial in the numerator, 3rd degree in the denominator. But what I'm going to do is we're still going to factor this out. So I'm going to factor out x cubed in the denominator. And then we'll end up here with 9 minus 5 over x cubed. And then I'll also factor out x cubed in the numerator. And this is going to reduce to x cubed plus x plus 1 over x cubed. Now the rest of this is pretty similar to the last one we did. So the x cubes are going to cancel. We'll have a bunch of terms going to 0 here. So let me rewrite this with what we have left. We're going to have x cubed plus x over just 9 here in the denominator. Now at this point, if we just plug infinity in here, we're clearly going to infinity in the numerator. So we've got an infinity over a 9 situation, but infinity kind of overpowers everything. So the 9 doesn't really do anything for us. So this limit's just going to infinity. And now in this case, again, we could just look at the highest degree terms. In the previous example, we had the higher degree in the denominator. Now we have it in the numerator. This just tells us we're going to be going to infinity, but we just don't know the sign. So really just looking at this, knowing we have the higher degree in the numerator, we could tell this is going to infinity. Okay, one last example here. And again, we have kind of an infinity over infinity situation when we plug in minus infinity. And I'm going to do the same kind of thing. We'll factor out the highest degree from the denominator. That's going to be x squared. This is going to give me 1 plus 8 over x squared. And then here in the numerator, we'll factor out x squared as well so that we can get that cancellation. This is going to give me x cubed minus x minus 1 over x squared. Now we do that, we get the cancellation here. This stuff is going to 0. Now we just have a 1 in the denominator now. So what we're looking at for our limit is we have x cubed minus x as x is approaching minus infinity. Well, this is interesting here. If you plug in minus infinity cubed, it's an odd power. That's going to a minus infinity. Minus infinity plugged in here, that's minus infinity, but because we have a minus sign in front of it, we have plus infinity. So because we have an infinity minus infinity, this is actually an indeterminate form. We can't conclude based on this what's happening. It could be 0, it could be infinity. Just from looking at this, it could be anything. But what I can do to be really sure about it, we can factor this again. So I'll factor out x cubed, and we'll end up with 1 minus 1 over x squared. But by doing that, this piece here is going to 0. We just have 1. Now we plug minus infinity in for x cubed. And then because of the odd power again, this is clearly going to minus infinity. So that's it. We've got some more limit videos coming soon. Thanks for watching. Have a great day.